Good afternoon and welcome to the 28th Annual Exhibit of Hydrogen and Fuel Cell Technology. Things are changing quickly and they're changing globally. It's always nice to return to the north after having been to the south this morning. We're off to Sweden and we'll be talking to Andreas Boden, who's Senior Vice President Strategic Sales for PowerCell Sweden, and we'll be discussing containerized fuel cell solutions. Andreas, welcome.
Thank you. It's good to be back.
It's good to be, yeah. This is not your first time here. How often have you come to see us here?
I think it's 10 times continuously we're exhibiting here. So.
Okay. So it's a strong presence. Let's talk about the company, first of all, PowerCell Sweden, and how the company started, how it evolved, and when did it actually get involved intensively with the fuel cell proposition?
Yeah, so it's PowerCell has a long history. We were originating from Volvo Group Research and Development during the 90s and was spun out from Volvo Group in 2008 and been operating independently since that. We started out actually doing diesel reforming to hydrogen and then hydrogen into the fuel cell to make small 3 kilowatt APUs for trucks. Because at that time, hydrogen was not the logistic fuel at all, and diesel were for the trucks where we originated that. So we worked with that for a couple of years and successfully did some field trials and that. But in parallels, we also started to engage in higher power, fuel cells for propulsion of vehicles. Because we come from the automotive heritage, and naturally going to trucks and buses and cars were slightly in our DNA then. We engage a lot in development of a high power stack, which we today sell as a commercial product called P-Stack. The development started 2013-14 and evolved in different generations. And finally now it's a product ranging up to 140 kilowatt. And we develop it to the angle for more commercial use, heavy duty applications like the truck, bus, off-road. But it also suits in other applications, which we come to a little bit later, of course, in the talk. And when we had this good stack with high power, we started to develop the system around it, integrated with blower, humidifiers, hydrogen controlled safety. Today we sell a lot of 100 kilowatt systems to various applications for aviation, marine, off-road, agriculture, and stationary, of course. I think what we learned in this journey was, selling a stack seems quite simple. It's a component, people can take it, but it requires a lot of resources on the customer side to integrate the fuel cell into the application. If you sell to a car OEM, etc., they have a lot of engineers who can, take on that challenge. But the further away you move from automotive, the less engineers are involved in development. And that's the reason why we started to develop the system as well, to be able to address a broader customer base the last years, which is, for a small aviation company or a ship operator, they have no idea how to integrate a fuel cell stack and barely a fuel cell system. So I would say the latest development we're working on and we offer to the market is, especially for the stationary market, but I would say it's a trend also slightly in the marine market. It's more towards containerized solutions, where we actually integrate the fuel cell system with electronics, safety system, cooling, and standard interfaces to make it so much easier for the customer to deploy fuel cells.
This is, we're going to have to parse a lot of this in detail here because it's so important. To go back to the beginning and the discovery, I have to say, the dirty past. So using diesel fuel to power a hydrogen fuel cell. I know there's a good answer to this, but we were often asked the question, why would you use a hydrocarbon to run a fuel cell? You have to reform the fuel, of course, and then you put it in a fuel cell. But what's the win? What's the gain for doing that?
Say if we turn back time a little bit, like 10 to 15 years, especially in Sweden, I think in Europe, diesel was considered to be clean. It was very efficient, and of course we had the NOx and particles, but the after treatment system, etc., made it clean in that time. And then we thought, like, diesel is a logistic fuel. We can go fill it on the tap and at the tank. And at that time, reforming the diesel to hydrogen and using the hydrogen in fuels was more efficient than using a small combustion engine to generate the power. So that was the driver to reduce the usage of diesel fuel, increase efficiency on the fuel you had. But also, since we did it catalytically, we didn't create any particles or NOx, etc. So it's also a way to make the diesel usage even more clean. But I would say it changed when COP21 in Paris changed that totally.
Swedish people are very kind, so he didn't mention the German-powered diesel crisis, the lies they told us about how good these vehicles are. Very nice of you to do that. Here it is a scandal, of course, added to which we're stuck with finding renewable energies to supply and make up for what we're going to lose in gas. But to get back to your company's strategy, you mentioned in 2019 a strategic year for your business model. Can you talk about that?
Yeah, so it's really a milestone, I think, both in the fuel cell industry for automotive, but especially for PowerCell. Then we signed an agreement with Robert Bosch. So they bought an exclusive license for using our high power fuel cells for cars, buses, and trucks. Which was a little bit of a pivoting point for PowerCell, because that was the way we have driven. And suddenly, that was not in short term, the commercial path we could take. So we had to start to focus more on the marine, stationary, off-road business, and then the last year as well as the aviation. But while we were good at developing this high-power, durable stack for heavy-duty application, the fit towards the marine and the stationary and off-road became quite obvious for us. So we had a little bit of setback there, but we gained the pace again, and attracting a lot of business now in the new segments, which is really fun to see how you can actually pivot a little bit based on a very solid core.
Speaking of solid, I mean, the main point, of course, is this integration into a system. Yeah. It's almost a plug-and-play thing, and this is the bane of the industry. 10 years ago, engineers with their lovely fuel cell on the stage here, and no one would know how to make it work within a system. What you basically want, if you're operating a system, let's say you have to convert a ship to electric, simply because we know there's many areas where they do not want the diesel pollution, the smokestacks pouring out obscene materials into an urban environment or along the coast, the beautiful coast of Sweden, for example. So there are laws mandating changes. But these people who operate ships, they really want to know how to spin the propeller, and they can get an electrical motor there, but they want electricity. Fundamentally, that is the integration side, and we're going to have to return to that to get to this whole containerized solution. I did want to go back to one of the core elements of your technology that really intrigued me. In the good old days, we would talk about stacks, and people would say our bipolar plates are, and then it got all complicated. And then there were these people who said metal bipolar plates, they're so sturdy. There's a downside in the old days. They used to say they're less efficient, but you can't break them. They're not as good, but you can't break them. The energy density is lower, but you can't break them. That is, for mobile applications where you have vibration, they were the thing to do, although there was a downside. Now, you solved that problem. The core of your technology is metal bipolar plates, right?
Yes.
Okay.
So we started out with metal bipolar plates back in 2001. And so we've been doing that for 21 years already. And of course, early we had these corrosion problems, getting metals into the membranes. But I would say the last 5-6 years, we don't see that the bipolar plate is the lifetime limiting factor at all. So when we do testing, both in the field and in the lab, and measure afterwards, we don't see that the degradation mode doesn't come from the plate anymore. I would say that problem is solved. So, working together in the industry with the suppliers and researchers, step by step, we have taken off the burden of the metallic bipolar plate. And I would say now it's more on the membrane side, which is the limiting factors, for the metal bipolar plate stacks.
Mm-hmm. Mm-hmm. On the marketing side, and your Vice President of Strategic Sales here. We love to think strategically here. While the market is slowly developing, we're thinking about strategy. So here's the strategy, where things change and why. In California is where most of the products arrive from China. So they arrive in ships. That's a pollution problem already along the coast. But the next thing is they're put onto trucks, because there is no rail system that really does this communication, and they're trucked across the country to Chicago and then on from there. And this highway that goes through California is called Cancer Alley. It's because the emissions of these trucks, and it's not easy to parse exactly why this is so, but they know it is related to diesel traffic, the intensity and the exhaust of these vehicles here. Well, there's a market. Simply because you have a lot of traffic, it's easy to put fueling stations in it. And what I'm saying is there's volume here. And the whole point behind these containerized solutions is to address the volume with a simple and also translatable concept. So where is the market for you? Are you going to California to see if the trucks will finally traverse the country without exhaust? Is it shipping? Are you going to clean up the coasts of Europe? Where's it going to be?
I would say the containerized products that we offer today is mostly related to the stationary side, and it's to make it easier for the customer. You just plug in hydrogen, get electricity out. We're taking care of all the integration of the power electronics, the cooling, all the safety, and I also think it becomes much easier for logistics and also for the authorities to approve, because then you have something that is already certified according to standards, and they don't need to bother how the fuel cell was integrated or what electronics was to be used. So I would say in that context, I think deploying the fuel cell where we have spare hydrogen. I would say when we're talking about the cargo vessels, of course you can replace the diesel APUs on the ship with hydrogen and fuel cells in containerized form, because they are used to handle containers. So that's one application. The other one would be cold ironing, power from shore to ship. And because most ports today will start to ban running the diesel generator to make energy for the ships while in shore. So shore to ship power is also a segment that we believe coming strongly. And then I would say, at least in Europe, we're using a lot of diesel generator to power construction sites temporarily. So having containerized solutions that you can transport from site to site also means that the customer does not need to invest in equipment. They can rather rent it or from someone, or it can be reused many times. And it's also from logistic perspective, it's very simple, because you can put it on the standard truck, move it to the next place, take a crane to lift it off, rather than every special design thing that we normally see or have seen in the industry. So I think it's containerized solution is the way to address a broader customer base, to make more people, taking care, implementing hydrogen and fuel cell in their daily operation.
It's funny how this addresses an issue we've always had. I've been here for 22 years. If you go back in time, we had a direct methanol fuel cell system that you could operate. It did exhaust CO2, but less than a human being breathing. Do you think we had certification to enter the building with this? No, we couldn't operate it within the building. It had to enter the building without any methanol in it. The first fuel cells we had ran on hydrogen. We needed pressurized tanks. Were there certification processes so that we get it through the door? No, there weren't. And this is one of the logistical factors. Certification is incredibly important. And what I like about the solution, and basically you've said this, but I wanted to underscore this. You certify the container. It doesn't matter where it is. You certify it, and then you're done.
Yes.
So you don't have to go for certification for this ship, and then this truck, and this aviation application. You have a certification for a unit. So it's kind of like a phone, a laptop, a device that you can carry with you or put somewhere.
And I think it's very important for the industry to get to that insight, that we cannot put the burden on certification on the equipment, on the customers. We need to take care of that as an industry. They need to take care of getting the permit to have hydrogen on site and doing the installation. That's their responsibility. But we cannot put the certification towards special standards related to hydrogen and fuel cells on every customer, because then we won't get anywhere.
Yeah.
So we need to we need to unburden the customer by making more ready solutions, which we already have today with our systems and this one. So.
There's so many jokes to tell about this. This is an important point, of course. In California, when we were discussing this topic, it is the local fire chief who has to certify things. That is literally the local in a community. You have to go to the fire department there, but it only is valid for that fire department in that location.
Actually, it's the same in Sweden.
Okay.
Yeah, it doesn't differ.
Oh.
And I think we put a lot of burden on that guy. And I think here, if it's people working in governmental position, this is a message to all. Please help the authorities, yourself, on lifting that burden from the local guy to more on an authority level with general standard guidelines. That would help the implementation of electrolyzer, hydrogen storage, and fuel cells a lot. So if there's anybody working with that here, please take that challenge with you from here. It actually limits the deployment currently in a lot of places in the world.
Yeah. It's this is the reference I made to California was simply, can you open up a fueling station? And there it became relatively difficult to figure out how to do it simply because of the certification process. This is a huge issue. Winding up on these topics, and well, should we mention, briefly Hitachi?
Yes, so for the stationary market, we're working together with Hitachi Energy for this containerized solution. So we're ranging from containerized solution from 250 kilowatt up to 2 megawatts. And why align with Hitachi Energy? Yeah, PowerCell, we come from the fuel cell and the fuel cell system. Hitachi Energy, which is a former ABB power grids, is really good at having equipment, knowledge to connect things to the grid or facilities. So combining our knowledge and products, we actually make something that we believe is great for a broader base of customers, that we unburden them. They don't need to integrate everything by themselves. We solve it for them. So it's a really good cooperation that the customer can benefit from.
I can't resist ending on a final note with a final question. We're talking with someone from Sweden. Welcome to NATO, from the bottom of our heart. Here's a country that's been spending 2% of its GDP responsibly for decades. We should think about that. On that level, though, you are now, and you've always been, by the way, really a cooperating partner. But what I'm aiming at here is there a specific European perspective now for applications? I'm thinking particularly of the issue of the shoreline and maritime applications. Do you see this as a location where hydrogen fuel cells and the hydrogen economy could really experience great growth in a very short period of time?
Yeah, so if we take that perspective, I would say Europe is a really melting pot now for hydrogen and fuel cell. But I think maritime sector is one of the areas we have a lot of focus on. And this year we're actually shipping a 3.2 megawatt fuel cell solution to one customer. So it's happening. We can see here in Germany, the inland waterways want to reduce the emission. Norway has a lot of initiative of implementing hydrogen and fuel cells on their vessels. We see initiative in other countries as well. So maritime industry is really thinking about what they will do when crude oil and diesel will be phased out. So they have the LNG, the batteries. But hydrogen in its pure form, or methanol or ammonia, is probably the bulk fuel of the futures. And I would say the further away you get from the coast, the more towards a liquid fuel it seems to head. So inland and close to shore shipping, supply vessels can run on either pure pressurized hydrogen or liquid hydrogen. We see initiatives now with methanol reforming a fuel cell. And there's also a lot of work now at research and development about cracking ammonia in pure form to feed to fuels, and also maybe burn in a combustion engine. But I would see maritime industries facing a huge challenge now with their logistic fuels. But hydrogen, in either an e-fuel or its pure form, is a serious alternative.
We have to end this here. We're over time, but it's a conversation we should continue at the booth, which is C60/1. I think it's in that direction.
Yeah.
I've been talking to Andreas Boden. who is Senior Vice President for Strategic Sales at PowerCell Sweden. Welcome to the club this year, and I hope to see you back here next year.
Definitely, Brian. Thank you.
Thank you, Andreas, and thank you.